let's do chapter 5, TAP4, A, because Nick asked me to, but B, because I in rushing through it, made a mistake yesterday in class. So remember from yesterday in class and from the given information of the problem, if we have pencils on the horizontal and pens on the vertical axis in our indifference curves, we have this bunch of indifference curves. All of them share the feature that their slope is -5, right? You're always willing to give up 5 pens for a pencil. And, we'd have a bunch of these all the way out through this space. But I'm only going to draw one, so this is going to get confusing enough or cluttered enough without that. Hopefully it'll be crystal clear. All right, well, let's suppose the individual faced relative prices that are less than 5 pens to 1 pencil. In that case, the budget line would be something like this. We'll call that B1, and we'd be at a corner solution like so. And this would be true for any, whatever situation. If the slope of B1 or whatever other budget we'd have were less than -5, we'd only consume pencils. All right, let me just label this U1. And then finally in the indifference curve space, or indifference curve budget line space, if we faced a budget line or relative prices where the trade-off between pens and pencil were greater than 5, we'd be at something like B2. And in that case, we're going to be at a corner solution that looks something like this. We'd only consume pens. The person is willing to give up 5 pens for 1 more pencil, but the market prices require them to give up more than that. They're going to say, screw that, I'm only going to use pens. I don't care. I only care about writing distance, and I can get the most for my money by buying pens. All right, well, what does this look like over in the demand curve space? And here's how it looks. Let's do Q, pencils per year. And we're going to express relative prices, P pencil over P pen. I wish I could normalize, but I normalize the price of a pen to 1, but that's not given in the problem. So this is going to always tell us the quantity of pens required to give up for 1 more pencil. All right, well, I was right up until the very last minute of doing this in class. At prices above 5 pens per pencil, whatever the price of a pen was. If a price of a pen were 2, the price of this would be the price of a pencil in nominal terms could be 10. But anyway, it's the ratio of the price of pencil to price of pen equal to 5. Anyway, then we wouldn't buy any pencils. So the demand curve would just be the y-axis. But then at a price of 5, the consumer of exactly 5, the consumer would be indifferent between having no pencils and all the pencils that his expenditure on pencils, which was given as y, pencils and pens total, equal to y divided by the price of a pencil. All right, and then after that is where I need to correct what went on in yesterday's class. After that, the quantity of pencils would be equal to y, the amount he's spending on them, divided by the price of the pencil. And this is for at prices below 5. So we'd have this function where we'd have this hyperbola. The price of a pencil equals y over q. It's the same. The inverse demand curve is easy enough to get. So that's the way it would look. And it wouldn't be a vertical line here. It would be this hyperbola. So that's an important point that I muffed in class. I apologize. Now you know.
Made with Doodlecast Pro.